This video is, let me make sure the volume is on. Yes. This video is addressing an issue with that drawing. So what I decided to do is I can work it by hand, but I wanted to double check it a different way. So the drawing is to scale, and it appears like I was trying to put the force 1/3 from E, the length of E to F. So what I did is I produced a CAD drawing. What you'll see is the distance from this point to this point in the X is 1, 2, 3, and it's in the Y as well. This roller right here can only produce a force directly to the left. In other words, as I push this down, the wall resists by pushing back this way. It can't hold it up. The roller can go down if it deflects a little bit. However, deflection is a topic for mechanics of materials, not for this course. So for right now, we're going to look at it like this. The force goes directly to the left. It has no vertical component at all. Well, if I want to do it with very minimal numbers, here's what I decided to do. The sum of the forces in the X and the Y are 0, but since it's a static member, the sum of the moments are also 0. What I discovered is that this point right here, and you'll have to give me a moment as this point right here is in fact a point in which all the lines have to coalesce through. What I mean, the lines are the actions of the load. So this load goes directly to the left. It's the wall pushing back on this beam. This is the place where the load was put. This one has to line up along that direction. There's another fact here. If I sum the forces in the Y, now, first of all, let me say that everything is to scale. That length is definitely not 1,000. But if I look at it and say, I'm going to multiply this times the S, this value times the S, and that value times the S, such that the S, or the scale, times that vector is 1,000, then that S times this vector will be its length, and so on. So everything is to scale as far as the vector lengths are concerned. The geometry, the length of the beam, the positions of all these points, that is to scale here. So I know that this force down on the base member here has to be, has to be in this direction. But that's definitely not its magnitude. So the key is how long is its magnitude? Well, if you sum the forces in the Y, what you'll notice, and again, this is the scale, this has no units in the Y direction. This has 1 unit, so therefore this has to be 1 unit. So this means if I were to, let's see if I could take this back off. I think I took the wrong thing off. Okay. If I were to draw this vector, I would have to go down 1 whole unit, to match the unit. So let me try to draw this. I can erase it in a minute. I'll say this vector has components. I'll go ahead and put the grid back on so that it's easy to do. Its vector is broken into those components. And this component. Now, it looks ugly, but I can change the arrow size to 0.4. I can change this arrow size to 0.4. So in other words, the the components of this vector is one to the right and one to the left. I'm sorry, one to the right and one down. So this means this vector has to go up 1, which means that if I were to go in and put a vector at this location, I need to take the grid off. I want to, this may take me a minute. Okay, I believe there we go. Now, what I will attempt to do, I will go ahead and try to move this vector out of the way, or that line out of the way. I will change its arrow size to 0.4 like the rest of them. And what I have here is a vector that is going in this direction. And the sum of the forces in the y means that this goes directly north, this one goes directly south. So I'm pretty much to scale here. So the question is what is the scale? Let's go in and look at dimensions here. We'll do a freeform dimension. From here to here, it should be 1.414, or so if I multiply this value times the scale, hang on, let me minimize this. So let me go down to the page here. Oh, what I should do also, I'll tell you what I'll do. I will drag this drawing over onto the page. I'll do a free form here. Okay. I don't really need that anymore. What I also would like to have is I would like to have the x dimensions. Let me I will have to approximate this one, but I don't have to. Wait a minute. I want the x I'll tell you what, let's zoom out. And I'll put this one right there. Okay, there's no particular reason to do the dimension from here to here, but let's go ahead now and use this snippet thing, snip the whole drawing, and what we'll do, we'll lay it back over here, say over in this direction. Now let's go back and work in this area. So here, wait a minute. Okay. If in fact this length is 1000, then I have to multiply this times the scale to equal 1000. So the question is what is that? I'll do it on the calculator off. Okay, so 1000 divided by 1.414, and it's throwing away the digits. So this is the scale here is equal to 707.2, and I'll say that's close enough. So now it looks to me like I did not, oh yes I did. So what is the length of this vector? Length of this vector is scale times that, or 1.054, or about 745. So it's possible that I made a mistake on that, but I'm going to just go with 745 for the moment. So if that were to scale, then this would be, I need to go back to it, 707.2 times 1 divided by 3, which gives me about 235.73, which means that this, okay, let's look at this. Okay, so you get a component going this way. Actually, that's too close to the color. I'll do green. So I get a component going that way. That is in fact 235. I have a component going this way, which is in fact 707.2, because this distance is 1, and the scale. So what happened to my, okay, so 235. It doesn't really matter what this value is for our problem. It does matter what the magnitude here is, which I got 735. So with that, let's go back and check and see if I did something and what I did wrong here. So first of all, we have our force here. We can, it looks like our geometry is the same here as it was in the CAD drawing. It's showing that I got a 800 here, but let's take a look at that. So if we sum the forces in the y, and that looks like that's where this came from, we get 1000 going down over square root of 2, and this we've had as the cosine of 28. Let me do this on my calculator off screen here real quick. I'm still showing 800 here, So my question is that, so if I'm looking at this angle, that may be my target right there. So in other words, is that truly 72? And if it is, then I have a big blunder here that you probably may or may not have recognized, and that is 72 plus 28 isn't 90. Oops. I didn't want to delete both of those. Hang on. I'll delete this, see if I can get that. And in fact, the issue, if I can get it, it's 18. So let's see if I can knock that out, put an 18 under there. Now, I'll go off screen and do the calculation, and what I have is 1,000 divided by 2 with a square root divided by 18, and after I cosine it, and I don't get 745, but let me do it again. Hang on. I'm going to start I get 743. Let me do it again. Yeah, 743. So my drawing, I get 745. Over here I get 743. So in fact, what you find out is these members, this one and this one, are off, scaled down. So if I did 743 divided by 800, each one of these would be 0.929 smaller. So this number would be 656. And this one would be 348. So I stand corrected here. What's interesting is because of superposition, all the answers will drop by that factor anyway. So everything you get will be smaller by whatever that percentage is. So I'll go ahead and post this. This is a verification that I was incorrect and I did not do my angles correct there. And you can see the advantage of using a CAD package, which this is Design CAD's pretty cheap. It's not full featured, but it will get you through geometry like this. So I'll go ahead and stop the video and say I stand corrected, and we'll go from there.